Now that you've got the basics of electricity under control, it's time to move on to controlling things with your Arduino. In this project, you'll be building something that could have been a spaceship interface in a 1970s science fiction movie. You'll make a cool control panel with a switch and lights that turn on when you press the switch. You can decide whether the lights mean engage hyperdrive or fire the lasers. A green LED will be on until you press a button. When the Arduino gets a signal from the button, the green light will turn off and two other lights will start blinking. The Arduino's digital pins can read only two states, when there is voltage on an input pin, and when there is not. This kind of input is normally called digital, or sometimes binary, for two states. These states are commonly referred to as high and low. High is the same as saying there's voltage here, and low means there's no voltage on this pin. When you turn an output pin high using a command called digital write, you're turning it on. Measure the voltage between the pin and ground, you'll get 5 volts. When you turn an output pin low, you're turning it off. The Arduino's digital pins can act as both inputs and outputs. In your code, you'll configure them depending on what you want their function to be. When the pins are outputs, you can turn on components like LEDs. If you configure the pins as inputs, you can check if a switch is being pressed or not. Since pins 0 and 1 are used for communicating with the computer, it's best to start with pin 2. Wire up your breadboard to the Arduino's 5V and ground connections, just like the previous project. Place the 2 red LEDs and 1 green LED on the breadboard. Attach the cathode, short leg, of each LED to ground through a 220 ohm resistor. Connect the anode, long leg, of the green LED to pin 3. Connect the red LED's anodes to pins 4 and 5, respectively. Place the switch on the breadboard just as you did in the previous project. Attach one side to power, and the other side to digital pin 2 on the Arduino. You'll also need to add a 10K ohm resistor from ground to the switch pin that connects to the Arduino. That pull-down resistor connects the pin to ground when the switch is open, so it reads low when there is no voltage coming in through the switch. Before you start, you should install the Arduino IDE or use the online IDE for Arduino. An IDE is an integrated development environment. Basically, it's a software application that helps programmers develop software code efficiently. Every Arduino program has 2 main functions. Functions are parts of a computer program that run specific commands. Functions have unique names and are called when needed. The necessary functions in an Arduino program are called setup and loop. These functions need to be declared, which means that you need to tell the Arduino what these functions will do. Setup and loop are declared as you see on the right. In this program, you're going to create a variable before you get into the main part of the program. Variables are names you give to places in the Arduino's memory so you can keep track of what is happening. These values can change depending on your program's instructions. Variable names should be descriptive of whatever value they are storing. For example, a variable named switchState tells you what it stores, the state of a switch. On the other hand, a variable named X doesn't tell you much about what it stores. To create a variable, you need to declare what type it is. The data type int will hold a whole number, also called an integer, that's any number without a decimal point. When you declare a variable, you usually give it an initial value as well. The declaration of the variable as every statement must end with a semicolon, winky face. The setup runs once when the Arduino is first powered on. This is where you configure the digital pins to be either inputs or outputs using a function named pin mode. The pins connected to LEDs will be outputs and the switch pin will be an input. The loop runs continuously after the setup has completed. The loop is where you'll check for voltage on the inputs and turn outputs on and off. To check the voltage level on a digital input, you use the function digital read that checks the chosen pin for voltage. To know what pin to check, digital read expects an argument. For example, digital read needs one argument, what pin to check. In your program, digital read is going to check the state of pin 2 and store the value in the switch state variable. Above, you use the word if to check the state of something, namely, the switch position. An if statement in programming compares two things and determines whether the comparison is true or false. Then it performs actions you tell it to do. When comparing two things in programming, you use two equal signs equals. If you use only one sign, you will be setting a value instead of comparing it. Digital write is the command that allows you to send 5V or OV to an output pin. Digital write takes two arguments, what pin to control and what value to set that pin high or low. You've told the Arduino what to do when the switch is open. Now define what happens when the switch is closed. The if statement has an optional else component that allows for something to happen if the original condition is not met. In this case, since you checked to see if the switch was low, write code for the high condition after the else statement. To get the red LEDs to blink when the button is pressed, you'll need to turn the lights off and on in the else statement you just wrote. To do this, change the code to look like this. After setting the LEDs to a certain state, you'll want the Arduino to pause for a moment before changing them back. If you don't wait, the lights will go back and forth so fast that it will appear as if they are just a little dim, not on and off. This is because the Arduino goes through its loop thousands of times each second, and the LED will be turned on and off quicker than we can perceive. The delay function lets you stop the Arduino from executing anything for a period of time. Delay takes an argument that determines the number of milliseconds before it executes the next set of code. There are 1000 milliseconds in 1 second. Delay 250 will pause for a quarter second. Thanks for your attention. Like and subscribe for more videos.